Hi everyone, and welcome back to the next episode in the series Learn GDScript the Hard Way, a very simple introduction to the amazing world of game development. This course is inspired by the book of the same name, Learn Python 3 the Hard Way by Z.A. Shaw. Since GDScript is very similar to Python, I felt that it would be a good fit to teach it in the same way. If you have zero or little coding background, then this course is for you, as it will take you through everything that you need to know and help you to understand it well, because you'll be doing it the hard way, by actually trying out everything that you see. Thanks to those who subscribed from the previous video, as it is your show of support which has motivated me to continue the series. Please consider subscribing to keep me going, and if you're already subscribed, hit the like button or comment some kind words below. Today, we're going to have a look at variables. As we begin our discussion of variables, here is some brief terminology on the board to help you. A variable is a named value, and a variable name is a label for a memory location where that named value is stored. Data is information that's processed or stored, and in actual fact, data doesn't become information until it is processed. A program is your set of instructions that perform a task, like playing a game or processing a Word document. Declaration is announcing your variable. Usually we do this at the start of a program. The value is that something that is stored in the variable, and initialization or assignment is where you give the variable a value. Let's have a look at this in more detail. We can think of variables as containers that hold information and allow us to access them later. Think of it as a box that has a label on it. The label is very useful because it means that we can refer to the box later. And by reading the label, we can already tell what type of thing is in the box. This is why it's very important to name your variables well. Ideally, they should be self-describing. You can also change variables after initialization. This is called reassignment. So you can use the same variable or box several times. However, if you rewrite a variable, you will lose the initial value stored. Lastly, we can use variables to store all sorts of different types of data. It is going to be limited by the programming language, but as shown in the diagram, integers, floats, characters and strings, and booleans are certainly options to be stored in a variable. Today, we're going to be learning about variables and the basic rules you need to understand to use them when programming your game. Here we have a little script I've written attached to the label, which is above the player's head. I've explicitly declared several variables here, and they are all the most important types. GDScript, like Python, doesn't require you to specify the type. I could just have easily created a string here like this, var my next string, and made it equal to this is what I am thinking. And if I replace the text of the label with my text, if I replace it with my next string, and we run the game, you'll see it works just as well. So you're not specifically required to declare the type of data by GDScript. However, I'm declaring it in this program so that I can teach you about the different types. The first type, and possibly the most important, is string data. What we mean by string data is a string of characters, a string of individual characters, all lined up next to each other to form words and sentences and so on. String data is essentially just text. Whatever you put inside these double quotes is going to be a string. These double quotes make something a string literal, a literal string. Another interesting fact about a string is essentially it is an array of characters. So what that means is it's a list of characters. So you can find out how long that list is, so you can get the length of a string. You can use other array functions on a string, which we'll learn about later on. The next type of data is integer data. Now, integers are whole numbers. So they have no fractional or decimal part. Their data type is called int, and you store a whole number in them. The next type of data is floating point data, or real numbers. Numbers that have fractional parts, have decimal values, and we call them floating point numbers. That little point or dot can float around depending on the size of the number. So here I've declared my real number, which is a float, and I've put 100.55. The next type of data that I've declared is a Boolean, and these are declared as bool. And Booleans can have two values, true or false. This could also be 0 and 1. They are binary values, opposites, and most often we just use them as flags to check if something is true, to toggle something, and so on. So here we have our game. He's walking around and he's printing out the value of the string on the label. If we had to try and print out the integer, so if I said my integer over here, and we run the game, you'll see that it doesn't run. It says the assigned values type, int, doesn't match the variable's type, string. So the label is expecting text. It can only output strings, but we're trying to let it output an integer. So we have to convert the integer into its text representation or the string representation. So to do that, we parse it, which means we convert it. So you put str in front of it and the brackets around it like this, and now it does something called casting or boxing. So it casts this int data in the mold of a string, or another way of thinking of it is it boxes up this integer into the package of a string so that it now looks like the text representation of that numerical value 100. And if you run it now, there you can see he's got 100 appearing over there. And the same thing would happen if we did it with the float. So if we put my real number there, without boxing it up or casting it to string, it wouldn't work. But if we cast it, we can now see the number above his head. And if we wanted to display the Boolean value, we could also say my Boolean. We also cast it, and now he's got the Boolean value above his head as well. A couple other things. There are some rules for assigning names to variables. The first rule is that you can't have a space your variable name. So if I put a space there, immediately an error pops up. It says expected an end of statement, but got an identifier. So as soon as you put a space in, the programming language thinks you're now assigning a new variable. So it thinks these are two separate variables, a variable called my and a variable called integer. So instead of spaces, we usually use the underscore character, or you use something called camel case. So like the hump of a camel, the first word starts with a lowercase letter and the next new word starts with a capital letter. That's also known as Pascal case from the Pascal programming language. The other rule for naming integers is you cannot start them with a digit. So you can't start this variable here with the digit 1. It immediately pops up an error, expected an identifier for the member variable name. It doesn't understand. As soon as you give a digit like that, it confuses the compiler. It won't work. And this is in all programming languages. So for your variables and your component names, make sure that you do not have spaces in them and that you do not start with a digit. Now the next one is not a rule, it's a convention, but your variable names, as far as possible, should be self-describing. So they should describe themselves. So my text, my next string, my integer, these are not self-describing. They don't really, just by looking at them, you don't really understand what those variables are for. Now in this case it was difficult to make self-describing names because this is just an example and there's no real application for this program. If for instance this 100 represented the player's health bar, you instead of calling it my integer, you could call it something like player health. And now that is a self-describing variable because you read it, player health, oh, this variable represents how much health the player has. Booleans, you usually want to start the name of a Boolean variable with the word is, because Booleans generally answer a yes or no question. So something like is jumping, and we can set it to true. So we can say is jumping is true. Now why would you have a variable called is jumping? Well, maybe you're creating a jumping mechanic and you want to find out if the player is already in the air. So if he's already jumping, you don't want to allow him to jump again, because then he will jump in the air and essentially you will create flying. If he just holds down jump or keeps pressing jump, he will just keep jumping up even if he's in the air already. So you want to detect, is he already jumping? If it's true that he's already jumping, then we don't allow him to jump again. If it's false that he's jumping, that he is jumping, then we allow him to jump because he's not already jumping. So usually Booleans, you would name them start with the word is, because it's answering a question. I hope that this video helped you to level up your knowledge of how to use variables in your programming and game development. That's all for today, and I hope to see you all again next time.